Greetings and salutations, my friends. We are heading into section 2.5, finding complex zeros of polynomial functions. So with this lesson, here's what we want you to be able to do. Execute operations with complex numbers, find complex zeros of a polynomial, and use the complex conjugate root theorem to find the zeros of a polynomial function. Hopefully you already know how imaginary numbers work and how to change a negative square root into an I. So here's the first fundamental theorem of algebra. This is our first theorem. Every polynomial function with degree n greater than or equal to 1 has at least one complex zero. In your homework, when they ask you how many complex zeros does it have, you're going to put what the degree is, because a real number is a subset of the complex numbers, so don't forget that. So every polynomial function with degree n greater than or equal to 1 has exactly n complex zeros. That's what I was saying. So if the degree of your polynomial is 3, it has 3 complex zeros. That's what it's talking about, because remember, a real number can be written as a complex number. So, complex conjugate theorem. This will help you when you are trying to find the zeros of polynomials. If p is a polynomial function with real number coefficients, and a plus bi, where b doesn't equal 0, is a zero of p of x. Remember, 0 is where the graph crosses your x-axis and where the y-coordinate is 0. Then a minus bi is also a zero of p of x. So if you know one, you know the other. That's it. We cannot take negative square roots, but we can extend out the number system by letting square root of negative 1 equal I, which hopefully you have seen in Algebra 2 and are seeing again. So I squared is square root of negative 1 squared, which is negative 1. I is known as the imaginary unit. Hopefully this is just review for you guys. So this one, square root of negative 100, I always think of this negative in front of the 100 popping out and becoming an I. So this is 10i, because it would be I times the square root of 100, and square root of 100 is 10. This one you'd want to break down a little bit. Pop the negative out and break the 80 down. So it would be I times square root of 16 times 5. I picked 16 because square root of 16 is 4. So here would be your simplified radical. When combined with a real number, we get what is known as a complex number, which is written in the form of a plus bi, where a and b are real numbers. A is considered the real part, and bi is considered the imaginary part. To add or subtract, you add or subtract the real parts and add or subtract the imaginary parts. That's all there is to it. I like to treat I like a variable and just go about my business like I would with an x or a k or something like that. And then if I have any I squareds, replace them with negative 1. To convert a complex number to a real number, you can add or multiply by its conjugate. So that's why you have to know what the conjugate is. Conjugate is formed by taking the opposite of the imaginary part. So if a plus b is your complex number, the conjugate is going to be a minus bi, and is denoted with a bar over the top of the a plus bi. This means the conjugate of that number. More for your money. Determine the conjugate of each. So remember, you only take the opposite of the imaginary part. So 5 plus 6i would become 5 minus 6i. This is a negative 2i. That's an imaginary part, so the conjugate is a positive 2i. Conjugate of 9, there's no imaginary part, so it would just be 9. You wouldn't do anything to it. So write this in the form of a plus bi, where a and b are real numbers. Just some more practice with imaginary numbers. If I pop that negative out in front, it becomes an I. So I would end up with negative 5 plus I times the square root of 4. Square root of 4 is 2. So I'm going to have negative 5 plus 2i. This one right here, same kind of thing. I'd pop the negative out in front of the radical. So it'd be 4 minus I. 4 minus 7i, and I could break it apart. I can either write it like this as one fraction, or I can break it apart, 4 over 2 minus 7 over 2i, and write it out like that. Here's some arithmetic operations with complex numbers. This is just an addition or subtraction, so all you do is you combine your like terms. And again, treat I as a variable and then replace any I squared you have with negative 1 and simplify it. It's all there is to it. So 2 plus 6 goes together to get 8. Negative 3i, negative 4i, that goes together, that adds up to negative 7i. When you have one where you're multiplying, I'd have 2 plus I times 2 plus I, and I'd FOIL it out. So 2 times 2 would be 4, outer and inner. 2i plus 2i gives me 4i. I times I gives me an I squared. This is the only thing I need to replace. I squared is negative 1, so I replace the I squared with negative 1 and add up my real parts. So I'm going to end up with 3 plus 4i. This one's on your sheet as a try on your own. So if you want to try this one, just pause the video here and give it a shot, and then I'll go over the answer when you turn it back on. Alright, so hopefully you got 5 plus 5i. So if I FOIL this out, I should have 2 plus 5i minus 3i squared. 2 plus 5i plus 3, 2 plus 3 is 5, so you'd end up with 5 plus 5i. If you didn't get that right and you're not quite sure, just give me a holler in class and I will be happy to help you. Alright, here's where we're getting into some sticky wickets. It says write the polynomial in standard form and identify the zeros of the function and the x-intercepts of the graph. Remember, x-intercept and zeros, it's the same thing. X plus 2, if that is a linear factor, then negative 2 here is a 0. Likewise here, I square root of 3 would be a 0, and negative I square root of 3 would be a 0. Notice these are conjugates, can't have one without the other. So what we want to do here is we want to go ahead and FOIL that out. We already know they gave it to us in linear factors, so we already know what the zeros are, but in standard form means we got to multiply this sucker out. Just FOIL it and take it a little bit at a time when you have these complex numbers. Don't get in a big rush. If you notice, this is x minus a number, x plus a number. That's a difference of squares. So you can take a shortcut there and say that's x squared minus I square root of 3 quantity squared. So if I square this one, I'd have an I squared times 3. And when I combine these, remember I squared is negative 1. So it'd be x minus a negative 3 or x squared plus 3. So the FOIL portion of this part is this x squared plus 3. And then all I need to do is FOIL out this second one. I just brought that x plus 2 down, and all I need to do is FOIL that out. So I would end up with x cubed, and then I take x times x, and then I'd have a 2x squared, and I'd have a 3x, and I'd have a 6. And so once I FOIL that out, that's the polynomial in standard form. The zeros, like we said before, are negative 2 and positive or negative I square root of 3. So that's one type of problem you might see. Negative 2 is the only x-intercept because remember, if it's a complex, it doesn't cross the x-axis. That's why it's imaginary. So it says write a polynomial function with zeros of 3 and 1 minus I. If 3 is a 0, you know right away that x minus 3 is a factor. Also, if I have 1 minus I as a 0, you know that 1 plus I is also 0. So we're going to have x minus this guy, and x minus this guy would also be factors of our polynomial. So we'd have x minus 3 times x minus 1 minus I times x minus 1 plus I. This is where you got to take it easy and take it slow and FOIL everything out. So we're going to go ahead and FOIL. X times x gives me x squared. X times the 1 plus I, I'm going to say, is a minus 1 plus I x, because this one's a minus in front of that parenthesis. And then the inner one would be x times this guy, which would be minus 1 minus I times x, and then 1 minus I times 1 plus I. If you take things slow and write them out and then just little by little go through and simplify, it will make your life a lot better. So this is going to be x squared, and we would have minus, if I take the x through there, minus x minus ix, and this is going to be minus x minus I, or plus ix, because we've got a negative negative. And then if I cancel, those two are going to cancel out, yippee skippy. And this one right here is a difference of squares, so it's going to be plus 1 minus I squared. When we simplify all that down, and 1 minus I squared is 1 minus a negative 1, I'm going to end up with x squared minus 2x plus 2. Bada boom. So from that whole mess, this is what it shakes down to be. Bring down your x minus 3, and let's go ahead and simplify that by foiling out. So I'll take x times all of these and then a minus 3 times all of these, and then combine like terms. So I end up with x cubed minus 5x squared plus 8x minus 6. So that's how you go ahead and do that with writing a polynomial with these zeros. You first get the linear factors, and then you multiply them all out. And by knowing these are the zeros, that gives you the linear factor. Let's see what's next. Write a polynomial with zeros of -1 multiplicity 2. -2i minus I multiplicity 1. X minus a -1 would be x plus 1. Multiplicity 2 means you raise that to the second power. If I know that -2 minus I is a 0, so is -2 plus I, its conjugate. So I'd have a linear factor x minus -2 minus I times the quantity x minus -2 plus I. Then FOIL it out. It's going to take you a minute, but take your time with it. So on this one, here's what you would end up with. So I would take x times x and x times the greenie, and then this x times the bluey. So you've got these, and then -2i minus I times -2 plus I. Combine all your like terms. So I multiplied through the parentheses by my x's, and I combined, I FOILed this thing out, so you get 4 minus I squared. Once you combine your like terms, you're going to end up with x squared plus 4x plus 4 minus a -1. So we end up with x squared plus 4x plus 5. So you might want to pause that and go through it and see how that all works. But try to FOIL it out on your own and see how you do. Then I'm going to have to multiply that times the x plus 1 quantity squared. Well, the x plus 1 quantity squared I have to multiply out before I can FOIL everything or distribute everything. So x plus 1 squared is going to be x squared plus 2x plus 1 times the quantity x squared plus 4x plus 5. Take your x squared times everything, your 2x times these three terms, and your 1 times these three terms. So I'm going to color code it. The x squared is the red line. The 2x is this purple line, so I took 2x times x squared, 2x times 4x, and 2x times 5. And then the green line, which is 1 times this whole polynomial here. When you combine all your like terms, and I like to write them this way so that the like terms are lined up, I end up with x to the 4th plus 3x cubed plus 10x squared plus 14x plus 5. And that's it. It does take you a little bit of time, but it's really not that tough. Determine the real number zeros and the number of non-real zeros, and then classify each zero. When you look at the degree, remember that is the number of complex zeros, because real zeros are also complex zeros. So right away we know we're going to have 2 complex zeros, and then we just need to see if any of those complex zeros are real zeros. So if I graph it, I notice that it doesn't intersect the x-axis. So on this one, there are no real zeros. The degree is 2, so there's 2 complex zeros. This one, you're going to have 3 complex zeros, and let's see if we have any real zeros by popping it in our graphing calculator. Yes, 1, 2, 3 real zeros. So it has 3 real zeros and 3 complex zeros. A real number is a complex number. All right, the last example. So it's saying here's this big long honking polynomial, and they want you to write it as a product of linear factors. That's what this is saying, x minus number times x minus number and so on, where n is the degree of the polynomial and the c's are the zeros. So in other words, we're going to have 4 linear factors because the degree is 4, so we're going to have 4 linear factors multiplied together to end up with this. Well, where do you start? This is where it all comes together. Your synthetic division, your zeros, and how it's all related. So first thing I'm going to do is pop that puppy into my graphing calculator. So right here, I get this graph as an x to the 4th. From before, you see how this ricochets back? That means it has an even multiplicity, so it's going to pop back up there. So right here, -3 is a 0. So right away, we know x plus 3 is going to be one of these linear factors. But this is a 0. Not only is it a 0, it's going to have a multiplicity of 2 because it ricochets back up. So this guy means that x plus 3 is a factor, and since the graph just touches at -3, the 0 has a multiplicity of 2, which means what we're going to do is we're going to say, okay, I'm going to do synthetic division with my -3 2 times. 2 times. I tell you 2 times. So what I'm going to do is I'm going to put the negative 3 in the box here. There's 4, 3, 2, 1, 18. So we don't need any spacers. And I'm going to do synthetic division. So it'll be times, and we'll go ahead and do the 1. Negative 3 gives me a 3. Negative 3 times 3 gives me negative 9. Add those, you get negative 2, and so on. So you're good with the synthetic division, I imagine, because that's fun, isn't it? If we don't get 0 here, we did something wrong. So this takes it to a cubic. So this would be like x plus 3 times x cubed plus 3x squared, and so on. But we know that this has a multiplicity of 2, so we're going to do it a second time. So we're going to take negative 3 and do a synthetic division with this quotient that we have, the cubic. What's going to be left is a quadratic, which we can factor. Woohoo! So we're going to bring the 1 down, and then we get a 0, we get a negative. So this means that I would have an x plus 3 as my two factors. And then this right here is x squared minus 2. So I'm going to tack that on the end. This is that fourth power factored. Isn't that cool? I know. You love this. I know you do. So x squared minus 2, the question is, how do we factor it? We know if it's a difference of squares, we can factor it. But what I would do is I would go ahead and just factor it as the square root of 2 and the square root of 2. So as a difference of squares, square root of 2 times square root of 2 is 2. The outer and the inner will cancel out, and bada boom, bada bing. That's it. That's your final answer. All right, so that ends 2-5. I hope you have a great day. Bye.